cube root. Anybody come up with a strategy for analyzing this? I don't really want the answer. Do you have a strategy for doing this? What did you do first to this? Anybody have an idea of one thing you could do first? Any idea? Yeah.
I guess.
You can guess and check. You could guess and check and see how close you get. Now, anybody have an idea? What did you guess first?
I guessed 0.1, so I just thought.
Like 0.1? Like that?
Yeah.
Yeah, so if you do 0.1, if you try that to test this, yeah, you have 0.1 cubed is 0.1, 0.1, and all that's doing is moving the decimal place over 3 times. So you can do it by guessing and checking. That's absolutely the case. There's something else you could do to help you analyze this. If you just saw that number, does anybody have a thought? When you see that, what do you think to yourself? Anybody? You might think of a topic we covered a while ago. Anybody? 10 to the... Yeah, exactly. 0.001 is 10 to the what? Negative third.
Hey.
This is a good bridge problem because we didn't go over this method yesterday, but we can definitely use it today. When you have cube root, what power is cube root? What? 1/3. Third would be cube. Cube root is 1/3 power. So this is, what is this? To the 1/3 power, correct?
Yeah.
But it's 10 to the negative 3. What do you do with powers of powers? What do you do with them? So this is going to be 10 to the negative 3 times 1/3. What is negative 3 times 1/3? 10 to the negative 1 is 1 over 10, which is 0.1. This is longer and then guess and check, but can you see how it works? It's kind of neat. When you see things you can write in scientific notation, sometimes it will help to write it in scientific. Not always, but in this case it does. In this case it does. This is kind of an advanced way of doing it, but what they expect you to do is exactly what you did, Connor, which is to think to yourself, oh, 3 decimal place, oh, 0.1. That's the level of analysis. What kind of number is this? That's even. And what kind of number is this? Negative. So therefore, what did I say you could write? Frowny face. The answer is imaginary.
Could you put 0 through the slash?
No, it's not. This means, hold on. I'm using frowny face because it's definitely not a real mathematical term. Don't do this because this means null set, meaning there is no answer. That's not actually correct. There is an answer to that. We just don't have the number system yet to define this answer. There are something called imaginary numbers. A brief. No, we'll talk about imaginary numbers in this class. Just to give you a brief preview, all of the numbers we look at live on this. What is this called? The real number line. The real number line. Any number that's not on the real number line is called imaginary. Real numbers have a letter in them. Anybody know what the letter is that appears in imaginary numbers? I. I is what appears. I, just so you know, I is defined as the square root of -1. When you define that, you can start coming up with answers to this. But have we done that yet? No. So right now you can write frowny face. I will know what you mean. You could say it's an imaginary answer. You're not responsible for figuring that out right now. If I just gave you the 6th root of 32, you want what times itself? 6 times is 32. 2 times 2 is 4. 8, 16, 32. So this would be 2. Just so you can get what the answer is. If you wanted to know what the answer to this is 2i. If you want to, just as a preview. You do not need to know that right now. This is just a preview. That negative sign. What do you do with that? You just keep it at the end. It doesn't change anything about the mechanics. It's just going to flip whatever the answer is. So the 5th root of that, another way to write that is the 5th root of 1 over the 5th root of 32. I'm just showing you how you could write this out. What is the nth root of 1 always going to be? 1. This is going to be 1 over the 5th root of 32. But now you need to remember, what is the 5th root of 32? 2. So it's just a half. But what's along for the ride? Negative. So it's going to be?
Sorry, what number is that again?
30.
Oh, -1/2.
Negative 1/2. Exactly. It's the opposite of the 5th root of 1 over 32.
2 to the 5th is
32. Correct. Correct. Yes, Liv. We counted wrong. Yeah. Look. 2 to the 1st. I started counting with my fingers wrong. Thank you. So look. Here, that's what I was kind of, what's the right way to say it? That's what I was kind of thinking to myself, like, wow, this is too nice. 2 to the 6th is actually what? 64, right? So here's the thing. It's not actually 2i. This is not actually 2, right? This is something between 1 and 2. Is it a nice answer? No. You either get a nice answer or a really nice not nice answer. There's no in between here. So over here, this is something between. All you know right now, this is what? And that's the calendar. I hate it when that comes up. Between 1 and 2, right? So on this one, you could just say it's the square root of 32i if you wanted to. But over here, just to get back to this, is it 2?
Yes. Or no?
This one is 2 because, sorry, this one is 2 because it's fifth root. Yes, I'm sorry. This one, good catch. No. Good catch. If we have some time, I'm going to show you something really cool with these answers to non-nice ones. So like the square root of 2. Do you know what that is in decimal form? It's 1.414. It keeps on going, right? All roots that aren't nice are irrational. Does anybody know what irrational means?
Yeah.
You can't write it as a decimal that ends.
Yeah.
So what's a rational number? That can be written as a fraction, right? We talked about that. What's an irrational number? You can't write it as a fraction. So the question is, how do you prove something can't be written as a fraction, right? It's a hard question to answer because how many different fractions are there in the world? Can you test them all? No, you can't test infinity, right? So you have to use a different logic to prove it. If we have time, I'm going to show you. It's pretty cool.
Oh,
Story. You ready for a fun story?
is it going to be a math story?
It is a math story. It's really cool, though.
Inspired you.
Okay. We've talked about this. What is a rational number?
Anything that can be written as a ratio.
Any number that can be written as a ratio. You should remember this because what's the first 5 letters? Rational number is a ratio. So any rational number can be written as P over Q, which is the most reduced form. So for example, let's talk about 0.75. 0.75 is rational because we can write it as a fraction. What is the most reduced fraction we can write? 3/4, exactly. What about 0.30? That would be 3 over 10. So any rational number can be written as a fraction in most reduced form. Are you with me so far?
Yes.
What most reduced form means is they have no common factors, meaning P and Q share no factors. P and Q share no factors. So this is all things you kind of know already. Are we okay so far? Okay, so let's talk about a number that's a little different though. The square root of 2. We don't think you can write that as a fraction, agreed? But we talked about this earlier. It's kind of hard to test all fractions because how many fractions are there? And you can't just check them off like, no, can you get closer and closer? Yeah, but you just don't know where this goes. So what we're going to do, we're going to assume the square root of 2 is rational and see what happens.
Wouldn't you write that over 1?
You could, but then the square root of 2. Oh, excuse me. It has to be these both have to be integers. P and Q both have to be integers. I'm sorry. So square root of 2 is not an integer, right? So yeah, you could write it as a fraction as the square root of 2 over 1, but is the square root of 2 an integer, Aubrey? It's not. Okay, so let's assume it's rational. What? An integer is any number that looks like this. 0, 1, 2, 3, -1, -2, right? Like that. So let's get back to this. If we assume root 2 is rational, what does that mean you can write it as? So root 2 equals some fraction P over Q. If we assume this is true, root 2 is some fraction. If that is true, could I multiply both sides by Q? If that's true, is this true? Is that true? Sure. If the first line is true, it follows that this is true. We're okay.
Well,
No questions so far. No questions. This is show and tell right now. This is show and tell right now. I'm taking you on a very specific story, okay? Every step I do is very specific. Very specific. Oh, already gotten tired? Okay. Oh, that's fine. You can sit if you need to see. I'm going to square both sides, okay? I am not telling you why I'm doing this. You just need to tell me if I'm allowed to do that. Could I square both sides? If I square both sides, what does the right-hand side become? What does the right-hand side become? P squared. Can someone tell me if I square the left side, what does the left become? 2Q squared. Because if you square the square root of 2, what is the square root of 2 times the square root of 2? 2. What's Q times Q? So am I okay to go to there?
Yeah. Wait, how'd you get there?
I squared both sides.
How'd you get to Q?
I multiplied both sides by Q.
Okay.
Q on this side and Q on this side. I cross-multiplied. Are we okay so far?
Yes.
Okay. If P squared is 2 times a number, if P squared is 2 times a number,
P squared is equal to 1/2.
P squared, what kind of number does P squared have to be? If P squared is 2 times a number, can you tell me what type of number P squared has to be? P squared has to be, I'll tell you, even. Do you agree P squared has to be even? P squared is 2 times a number. P squared is, so 2 has to be a factor of P squared. What's the definition of an even number? 2 is a factor, right? 8 is an even number because 2 is a factor. 16 is an even number because it has a factor of 2. A billion is even because what's a factor? 2. So are you okay that P squared is even?
Yeah.
Okay. Side note. Think of an odd number. Is everybody thinking of an odd number in their head? Yeah, exactly. Wow. Everybody has that odd number in their head? Don't make it too big. Make it a little small. Take that number and multiply it by itself. Have you done that in your head?
Yeah.
The number you're thinking of in your head, is it odd?
The one that
The new one.
Okay.
The product. Is the product odd?
Yeah.
No matter if you start with an odd number and you multiply it by itself, you always end up with a. Do you agree with that?
Yeah.
It's like 9 times 9 is 81. 7 times 7 is 49. 3 times 3 is 9. An odd times an odd is an odd. What about an even times an even? It's always going to be what? Even. It's always going to be even. Are you okay with believing those two things? Okay. So what did we come up with right here? P squared is even. So we know that P times P is even, right? So therefore, what can you tell me about P? P must be what? Even. You just told me that an odd times an odd is an odd. An even times an even is an even. You know that P times P is even, so therefore, that's what those 3 dots means. P must be even. Are you okay with that?
Yes.
Do you believe that P, this is really important that you pay attention up here. Yes.
How do we know that P squared is even?
We know P squared is even because 2 is a factor. We know that P squared is even because 2 is a factor, right? We know that an odd times an odd is an odd. We know that an even times an even is an even. Therefore, P must be. Are you okay with that, at least generally so? Yes.
Anything multiplied by 2 is going to be even.
Correct. Anything multiplied by 2 is even.
Well, how do we know that 2 is a factor?
Because I have this statement right here that we know is true. We know that P squared is 2 times something, right? So 2 must be a factor, right?
Yeah.
That's what this says. So all I want you to be okay with right now, do you agree that this is true right here? Okay. What does it mean for a number to be even, Alex? What does it mean for a number to be even, Alex? It's divisible by 2. So P is equal to 2 times some number, let's say K. Does that make sense? It has to be equal to 2 times something. So what we're going to do is we're going to go back to the story here. This was like a side note. We're going to take this and plug it in here. So we now know that 2q squared is equal to 2k squared. Where k is just some integer, okay? We're just following a story here. What's 2k times 2k? 4k squared, exactly. 4k squared. Can we simplify that a little bit? What can we divide both sides by?
2.
So what do you get now? Q squared is equal to 2k squared. So let's talk about that for a second. We know that q squared is equal to 2k squared. What can you tell me about q squared? It must be what? It must be even. So therefore, q times q is even. So q must be what? It's the same logic before, right? So let's talk about this. We just proved q must be even, right? Let's go back up here. Wait, just stop for a second. I'm getting to the punchline. We know q must be even now. But, this is important. Hey, how you doing? But what else do you know? You know that p must be even. Do you remember this one you were okay with? Let's go back. You know that q must be even, and you know that p must be even. They're both even. But what did we assume at the beginning?
They're rational numbers.
Oh, they're most reduced forms.
If we assumed that p over q was the rational expression, right? But we just showed that p is even, and we showed that q is even. If you have an even over an even, what can you always do? You can always cancel the 2's out, right? You can always reduce. So they're not reduced form. So here's the thing. Everything we did is a legal operation. If everything we did is a legal operation, is legal. If everything we did is a legal operation, what does that mean about our original assumption?
It's not rational.
It means this is false, right? This was our only assumption. If all of our work is correct, and I'll tell you it is, we just showed that the original assumption is false. So therefore, the square root of 2 is not rational. What's the only other option?
It's imaginary.
It's irrational. Irrational.
I don't get it.
Listen. A number is either rational or it's irrational. We just showed it can't be rational, so therefore it must be irrational. This right here, it's really okay if it totally doesn't make sense 100%, because you know where you learn this usually?
Pre-calc.
Second or third year college mathematics.
Oh, awesome.
This right here is number theory, right here. This right here is number theory, but here's the core element. We assumed you had to have this to exist if P over Q is relatively prime, meaning it's most reduced, like 3 over 4, is that most reduced? But we just showed that P is even, and we showed that Q is even. So therefore it is not most reduced, so therefore this is false. So if this can't be rational, it must be irrational.
If they're even and you cancel one, it just equal 1.
No, if they're even and they cancel, it'd be like 6 over 8. 6 over 8 translates into 3 over 4. But what we just showed, if you think you have the most reduced, do you ever have the most reduced? No. So therefore it can't be rational, which was our only assumption. So therefore it must be irrational. Think about it this way. Think of an integer in your head. I'm thinking of an integer. Ready? I'm thinking of one, right? I'm telling you, it's not odd. What do you know it must be? There's only 2 choices, right? Hey, we just showed it's not rational, so it must be irrational.
Yeah.
Okay, so you just learned something that's about 6 years above your pay grade. How do you feel? Cool, awesome. Okay, you can sit down. Go ahead. Sit down. To math education is that many people walk into a math classroom and they feel like this.
Yeah.
One of the reasons they feel like a math classroom is because you don't see the end game. What I mean by that is, how many people have taken an art class before? When you go into an art class, do you have an idea what a Picasso might look like, or a Renoir, or some Degas, or some amazing sculpture? Have you seen those things?
Yeah.
You understand functionally when you walk into an art classroom that when I learn how to paint a fence, or I learn how to paint a barn, I might be able to one day put it together into some impressionist watercolor, right? You kind of understand where you're going, right? One challenge with math education is you don't see the end game often enough. You don't get to see the masterpieces. So you learn how to, functionally in a math class, paint a fence, but you don't understand what the entire landscape looks like, unfortunately. So my hope with that is that you can kind of get to see and feel what it's like to learn and operate in mathematical spaces that you might not get to until your junior, senior year of college. But here's the thing. This might have been, as I showed you, was this a little complicated? Sure. Did you how many people understood at least some of what I did right there?
Yeah.
You just understood some of junior level mathematics. In math major land, this is beyond what you would normally take in your math requirement in general. This is what you would take. So the point is, one way, hopefully, I'll get you to feel less like this is to show you some of the end game. Does that make sense?
Yes.
Okay. Ready to get back to Algebra 2?
Yeah.
Okay, let's get back to Algebra 2. Okay, Algebra 2 lands. So we get to move to 8, the second half here of 8.1. The second half of 8.1 gets into a little bit of fun, which is this right here. Y equals the square root of x. Do you understand what that means? Has an equal sign. It's an equation. It's a function, right? We're going to have a little contest. By yourself, draw me a picture as accurately as you can of what that looks like. You have 2 minutes to draw me a picture of what that graph looks like. Any way you want. You could do it on your surface. You could draw it on your desk. Whatever you would like. I just want to see you draw me what you think that looks like right now. It's okay if you have no idea. Make a guess. Then we're going to analyze what you come up with. At first, by yourself, no questions, tell me what that looks like. So you have a question. There's an invisible 2. That's correct. This is square root. Yes. 0. Square root of 1.
1, 2, 3.
Yeah, I picked the 1, so it would be succession like this. So what point is this right here? 0, 0. The origin. 1, 1. 4, 2. 9, 3. 16, 4. And 5. So what am I in? What quadrant am I in?
You're in
quadrant, so first.
The first quadrant, right, exactly. So I'm going to approximate. Is it okay if I approximate these points to begin with? Is that okay? So what do I end? 0, 0, 1, 1, 4, 2, 9, 3, 25, 5 is over here. So if you connect these, what does it look like? Curve like that. It's not a straight line. It's not a straight line. It will keep going because here's the thing. Can you take the square root of any number you want? That's bigger and bigger? Yeah. It keeps going because no matter what number you choose, I always choose a bigger number. You can say the square root of a billion. I can say the square root of 2 billion, right? It keeps on going. Does this thing always go up? Sure. But it goes really fast this way.
Wouldn't you just go with this?
No, it never comes down because look, if I take the square root of a bigger number, it always gets bigger, right? It's always going to get bigger. This is the kind of shape you need to be familiar with right now for the square root of x. The square root of x. I have a question for you. This table right here, I started at 0, right here. I started at 0. Why didn't I start at like -1 or -4 or -6? It doesn't exist. The domain here, and they don't talk about this right now, but what's the domain of this function? X such that x has to be greater than or equal to 0. Because can you plug in anything negative? No. Let's change it up just a little bit here. You see what we ended up here? We ended up with this nice picture. Let's change it just a tad. I want you to do the same thing. I'm not going to give you a hint, but I want you to do the same thing, but I want you to do cube root of x. Show me what that looks like right there. Show me what y equals the cube root of x looks like. Do the same exact. Think about this one for a second and be careful. I'm going to take a vote. You have 3 words to describe what this is. I'm going to give you a few choices. Take 30 seconds to think about what you think happens. I'll give you one hint. The shape doesn't change. The shape doesn't change. I'm going to ask you in 30 seconds what happens. Don't say, why don't I want to plug in 9 into that, Mark?
Even.
No, what's 9 plus 2?
11.
Do we know what the square root of 11 is? No. So what would be a good number to plug into there? Really?
No. 47.
That would be good, actually. Sure. Can someone give me what's the smallest number you can think of that would be great?
2.
How about we plug in 2? What's another number we could plug into there? How about 7 and then 14?
Wait, what?
I like 26.
7 plus 2 is 9.
What's
Oh, yeah.
okay, everybody? If I plug in 2 into this, what's 2 plus 2?
4.
Square root of 4 is
2.
2. Okay, so 2 outputs a 2. If I plug in 7, what do I get out? 3. If I plug in 14, what do I get out? 4. So how about 23? What do I get out? 5. So these all correlate to points. What points do these correlate to? 2, 2, 7, 3, 14, 4, and 23, 5. I'm going to plug in one more point. Could I plug in if I wanted to?
34.
Can I plug in -2?
Yes.
I can, because what's -2 plus 2?
0.
0.
And then it's
Oh, so what point is that? -2, 0. So if I take these points, everybody, and I plot them, what happens? The curve stays the same, but where did it start? The negative side. So this right here is y equals the square root of x plus 2. What does this represent right here? The square root of x. Y equals the square root of x is right here. Y equals the square root of x plus 2 is right here. The curvature didn't change. How did it move? 2 to the left. 2 to the left. 2 units left. Exactly. So now you know. What about y equals the square root of x minus 2? 2 units right. Exactly. So you can put this all together, and I could ask you this. Y equals the square root of x plus 2 plus 3. Can someone tell me how you would start with this, and what would you do to it? What's the first thing you would do? Left, how much? 2 and up 3. So you would start with the graph of, here's y equals the square root of x. What would you do first? Left 2. So you would go to like this. So that's y equals the square root of x plus 2. And then what would you do? Up 3. So it would start like up here. Y equals the square root of x plus 2 plus 3. And now you have the graph. It's a little counterintuitive because usually when you think of positive, what direction are you going in? Up or right? Not in this case. When you add 2 on the inside of the square root, what happens? 2 to the left. It moves it 2 to the left. It's the opposite. Inside opposite. You'll get a handle on this. Which is yesterday we talked about this. And that's a really too thin. You can't really see that, can you? A to the 1 over n. That was equal to the nth root of a. You remember that? We talked about that yesterday? We talked about that? Okay. So, do you see this number right here? Everybody see that number? What happens, let's say if I raise this to the 5th power. You can do the same thing to both sides. What happens with powers of powers? What do? You multiply them, right? So what number does 5 get multiplied by? 1. The 1. So if I did this, what do I end up with? A to the 5 over n equals, I'm going to keep this the same. I'm keeping that the same. So I'm going to go one step further. I'm going to ask you a different question. You already know that this is true, right? A to the 1 over n is equal to the nth root of a. I'm going to raise both sides to the m power. What do you do with powers of powers? You multiply them. So what does this become? A to the m over n is equal to the nth root of a raised to the what power? M. And again, this is tragic. I know math kind of disappoints you when it uses m and n and p and q. They look and sound the same, right? It's kind of annoying, right? This right here is super important because m over n can be any what type of number? Any rational number. It can be any fraction, any rational number, exactly. How many numbers is that? A lot of them, right? A ton of them. Why is this useful? Let's say I asked you for this. 8 to the 2/3 power. Oh man, what the heck does that mean? Let's look at the definition here. Can someone translate that to what it means using that formula? What root is it? It's the cube root of what number? 8, all raised to the what power? Do you know what the cube root of 8 is? 2. What's 2 squared? 4. You just did your first rational root. First rational root. The way I asked a really good question was, could you do it in a different way? You could, if you wanted to. You could do it as 8 squared to the 1/3. Right? Because what is 2 times 1/3? 2/3, right? Well, what's 8 squared? 64. So you have 64 to the 1/3, and you know that equals 4. Here's the thing. Can I ask you a question that says about which path looks a little easier to deal with? The first path or the second path? I think the first path is easier to deal with because why?
Because we know that we can find bigger numbers.
Let's be simpler than that. How does 8 compare to 64? Smaller numbers are generally easier to deal with. This is totally valid. Absolutely. But if you can stay with smaller numbers, stay with smaller numbers. Absolutely. So here's another one for you. What does this mean? Right. Let's do this. 27 to the 2/3. What does that mean? Can someone explain what that means? The cube root of
27
to the... what's the cube root of 27? Squared is?
9.
Yeah, you just did another rational exponent. Fantastic. Let's do one that looks really scary. What about 36 to the 3/2? Can someone else tell me what that means? Summer, what does that mean? What does that mean? What root are we dealing with? We're doing the 3/2 power, so what root is it, Nick?
6 to the 3rd.
Yeah, it's going to be the square root of 36 to the what power? And that's going to be 6 to the 3rd, and you might remember that's what? Remember what that is? It's 216, yeah. What about this one right here? 16 to the 3/4. Can someone tell me what the intermediary, what the radical, how you could write this differently? Milo, what is it? Yeah, 4th. fourth root of to the what power?
16.
To the third. This number goes right there, and this number goes right there. What's the fourth root of 16? 2 cubed is 8. So do a lot of these work really well?
Yeah.
Absolutely. Generally speaking, or you'll run into a wall really quickly. And when you do, the only thing you can do is a calculator. Because do I expect you to do square roots by hand? No. I do not. I do not. Okay.